So on this video we're going to use InspectionWare to label the indications on the radiography image that we straightened in the last video. So we'll go ahead, and this is the image from the last video, and we'll drag that out here. And you remember we have to put the horizontal so it's going in the right direction, and I'm going to do select gray inverse on the palette, and we have a standard radiography view. I'm going to put this down here and flip that view too. And as before, this one's pinned, we'll keep it on the top, and then this one will follow our tree. Okay, so let's go ahead and build our data processing tree. We're going to start with a couple of FIR filters, 2D, 1D, and put a label peaks on the end. Okay. So let's go ahead and set these up. So this one, we right click and configure this in the vertical direction. 72 points, and we're just doing an edge detect. And just in case you're saying vertical, remember we've twisted our plot, so the vertical is really the horizontal direction. So I'm just going to run that, press F5 to execute, and you can see we've pulled out the edges here. Okay, so we're going to keep going in this direction with the 1D filter, and I'm going to put it as a pulse. 20, let's do 21 points, a period of 11 points, a width of 11, a height of 1. And let's just see how that looks. There, and it's pretty saturated, so we're going to just get rid of the auto normalization, which is putting it at -11. Try that, 0.4. And this one, that looks pretty reasonable. I'll turn on this cross section, and yeah, we're not saturated yet. That looks pretty reasonable. Okay, so now the label peaks. So what we're going to do with this one is we're going to detect zero crossings, and let me put this back here. And how this one works is it runs along the first axis, which is up in this case. When it hits a zero crossing, it tries to track it across to the right, and it tracks it as far as it can, and when it finishes, it declares that area as an indication and labels it with a given number. So we need to set some properties. So the peak width of 8 points is a reasonable number. Search width is sort of when it switches to the next line to the right looking for the peak. It's going to look on a search width of 8 points there, so a little bit up, a little bit down, but not too much. Give it a minimum length of 72. Gap tolerance, we can do 24, so that means it'll keep searching even if it doesn't find a zero crossing for 24 points, and looks there and look for a valid zero crossing. And the threshold, I think, I'm going to try this at 33. And what that means is once it crosses, finds a zero crossing, it looks either side of that within the peak width value to see if it's gone up or down by 33%. And that stops us from getting the noisy zero crossing. So I'm just going to press F5 and see how that works. Actually looks pretty good. I'm going to right click on the palette. This one here. That's pretty good. So now we have all these indications labeled here, and all the label is it's just a number. So this is indication 31. You read it up in this cursor readout here. 16, and so on. So we just have a bunch of indications, and if we shift double click on this icon here, we can see that these have been turned into a table. Not very user-friendly at this point, but it will be after we process it a bit. But it's saying these are the pixels start, end in X, Y. It's not three-dimensional, so there's no z-axis here. The width and a bunch of other properties, but we're going to tidy these up as we keep working on this. This is the number of hits and the raw minimum, raw maximum, things like that. There's an ID on these two. Each one gets a unique ID which progresses as you run the program, so it's unique over the life of the program that you run. Okay, so now we've got our labels, and up here off screen I'm pressing Add Indications Loop, and just going to drag this down here and you'll see what that's done. And what that's done here is it's given us a loop that when we finish finding the indications, it'll put each of them through this loop and we can do data processing on them. And if I drag this guy out over here, and I think I'm going to pin that so we don't lose it, and I run this, you can see it fires through all the indications. We haven't done anything with it yet, but we have the opportunity to. And so this one is now looking one up the tree, so it's looking on this filtered thing. I'm going to pin it again so I get the following behavior. But I can also go back to my original thing and make a connection, and that's then going to follow that. So I'll put this one back here. I think I need to pin that so I don't lose it. I run this again, and it goes through on the original unfiltered data. Okay, so let's add a few more things in here. So we're going to do peak indication. And I'm going to hook that up to Weld. So this is the peak in the original thing, and indication noise stats. So here we go here, and flip this property over to connection, and I'll let this run again. You can see what happens, and you can see a bunch of numbers going by, and what the difference with these things is the peak in the Weld, it's gone up to the original Weld, so this image here, and it's found the peak in all the indications, and the indications back. So you can see them, and it's given the peak, max, at the peak of the filter data, maximum, min, extreme, average. Now the noise is an interesting value. What it does is it says, I'm going to take a box with a little bit of extension on it, and I'm going to blank out the signal and just look at the background. So that's an interesting one, in that you can pick out a peak and then look what's happening around it. So now we've got these three things here. I'm just going to throw a processor on here, and I'll show you how the neat thing we can do now is we can get numbers from here into the table. And we do this as follows. So we go to this, let's pick this maximum, or why don't we pick out the average of the indication, and we double click on this output, and then we put, how about peak average, and then we go down to the noise, and we put noise average. Okay, and then we do a tricky thing up here. We go up to this, we go to developer tools, and we do find internal data columns. run that, and sorry, I'll just do it on this properties here. And you can see that it's put these things in internal data columns. And we can, for this one, it's a tricky thing you have to do. Sometimes this will overwrite that usage I'm putting on the output, so we're going to put this sync output usages to false. Always do that. These other ones have it already false. Double click on here, and let's just put medium. Doesn't really matter for now. And then we go back here, find internal data columns, and then we run this. And we scroll over here. Oh, I think we didn't catch those columns are there, but they're still empty. So we're going to run it from the root. So execute processors, and that's all run. We saw it running. Double click on the grid icon, and we've captured all our median values. Okay, so now we've labeled these indications, and we've done a very simple internal tree to capture a few properties of them. And I think in the next video we're going to sort of make this a bit richer and continue working on the process in the table after this point. Okay, that's all for now.